conquer my country's heart, they rise to fame. She is eternal, long before nations.
Hello, everyone, and welcome to another amazing episode of the Geo-Legends series. Here today with Mr. Dr. Kerry Rowe. What an honor it is. My name is Ryley Beddoe, and I really do have the privilege of serving as today's interviewer for this episode. My connection with Kerry goes back nearly 20 years to when I was a master's student under his supervision at Queen's University in Canada. And since then, he has remained an important mentor and a colleague, and I am so grateful and honored to be here today. But before we begin our conversation with Kerry, I'd like to take a few minutes to share a little about his background and the remarkable contributions he's made to geotechnical engineering. So let's start at the beginning. Professor Kerry Rowe was educated at the University of Sydney, Australia, where he earned a Bachelor of Science in Computer Science and Mathematics in 1973, followed by a Bachelor of Engineering with a first-class honors University Medal in 1975. He completed his PhD in 1979 and later a Doctor of Engineering in 1993. In recognition and contribution to science and engineering, he has also received honorary doctorates from Western University and the Technical University of Bucharest in Romania. Back when he started, Kerry was a cadet engineer from 1971 to 74, after which he began his career as a geotechnical engineer with the Commonwealth of Australia Department of Construction. In 1979, Kerry made the big move to Canada to join the University of Western Ontario, where he spent 21 years as a professor, 8 years as chair of the Department of Civil and Environmental Engineering. From 2000 to 2010, he then served as the Vice Principal of Research at Queen's University, where he oversaw the university's research portfolio, including the Sudbury Neutrino Observatory Experiment, so the SNO Lab, which later led to the Nobel Prize awarded to Arthur MacDonald. Professor Rowe later held the Canada Research Chair in Geotechnical and Geoenvironmental Engineering from 2010 to 2024, and currently serves as Distinguished University Professor in Civil Engineering at Queen's University. Over more than 4 decades, Professor Rowe has been a pioneer in the development of geoenvironmental engineering, particularly in understanding and improving barrier systems used to contain waste and protect soil and groundwater. His research has advanced his long-term performance of landfill liners, geosynthetic clay liners, and HDPE geomembranes. His team is the first to quantify geomembrane wrinkling and demonstrate how it affects leakage in landfill contaminant systems, work that has changed landfill design and construction practices worldwide. His research addresses emerging environmental challenges, including demonstrating the current landfill systems may not adequately contain PFAS, and highlighting the need for revised regulatory approaches. Beyond academia, Kerry has consulted on more than 240 geotechnical and environmental projects worldwide, including over 90 landfill and containment facilities. His work developing solutions for environmental protection and waste containment have taken him from the Arctic to the Antarctic and every continent in between. Over the course of his career, Kerry has supervised over 140 graduate students, including 105 PhD students, along with 36 postdoctoral fellows from Canada and around the world. The work that he and his students have carried out over those 4 decades have helped shape modern understanding of waste containment systems and environmental protection in geotechnical engineering. This work has resulted in more than 470 reference journal papers, 3 books, 19 book chapters, and nearly 300 full conference papers, with an H-index approaching 100 and tens of thousands of citations. Over the past 4 decades, his work has been recognized with more than 150 awards, including 26 Best Paper Awards, multiple International Geosynthetics Society Gold Medals, and the Thomson-Telford Gold Medal for the best paper published across all journals of the Institution of Civil Engineers. His impact as an educator has also widely been recognized through major teaching and graduate supervision awards, along with the Miroslav Ranowski Medal from the Royal Society of Canada for the exceptional scientific work addressing environmental problems. His influence on the profession is also reflected in the many distinguished lectures he has been invited to deliver around the world. These include the Giroud Lecture, the Rankine Lecture, the Manuel Roker Lecture, the Casagrande Lecture, the Terzaghi Lecture, the Mercer Lecture, some of the most prestigious lectureships in geotechnical engineering. But perhaps the clearest measure of his impact on this profession is that today, 2 international lecture series now bear his name. The ISSNGE R. Kerry Rowe Lecture, established in 2013 for seminal contributions to the geoenvironmental engineering field, and the International Geosynthetics Society Kerry Rowe Lecture, created in 2021 to recognize his pioneering contributions to geosynthetics engineering. His contributions have been recognized more broadly through election to some of the world's most prestigious scientific and engineering academies: the Royal Society in the United Kingdom, the US National Academy of Engineering, the Royal Society of Canada, the Canadian Academy of Engineering, and the UK Royal Academy of Engineering. In 2018, he was appointed an Officer of the Order of Canada, and in 2024, he received the Gerhard Herzberg Canada Gold Medal, Canada's highest honor for non-medical scientific research, recognizing the global impact his work has had on environmental protection and the safety of communities living near waste disposal facilities. Today, we are delighted to welcome Professor Kerry Rowe to reflect on his career, the development of geoenvironmental engineering, and the lessons learned from more than 4 decades of research, teaching, and practice. Kerry, welcome.
Thanks, Ryley. That was a rather long introduction, so I'm not sure there's much else to talk about.
Nice try. It just gets it's you know, and it's hard with a career that you had. I mean, you can recognize that there's a lot that was already cut out. So it's a formidable career to talk more about it. And really, I think maybe to start our conversation, I'd love to go back to the beginning, and hoping you could tell us a little bit about your early years and what first motivated you to become an engineer.
Well, that really does go back to about 1955, when we moved, my family, I was a little kid, of course, moved to a construction town called Adaminaby Dam, where they were building the main dam in the entire system that was directing water that usually flowed to the Pacific in the opposite direction to the west and generate a lot of power on the way. And so we moved down there, and it's a town that just appeared. A whole lot of trucks came in, and what was farming land became a town. And we lived there for about 3 or 4 years until the dam was completed and the town just disappeared again. But those were rather formative years, and I just loved watching the dam being built and decided I wanted to build dams. So that was really the beginning. It was interesting that decades later, I was in a meeting in Ottawa with NSERC, the Natural Sciences and Engineering Research Council, and one of the other people there was Professor Bruce Hutchinson. And we got chatting, and we discovered that we were both in Adaminaby Dam at the same time. I was a kid, and he was a young engineer on the project. So it's a small world.
It is definitely a small world. Yeah. So when you're talking about sort of moving, I understand that your father was a public servant who kept getting promoted by moving to where there was opportunities. So how did that in turn affect you in having to sort of change friends, change schools on a regular basis? And did that sort of add influence?
Well, it was somewhat challenging. For the next 5 years after we left Adaminaby Dam, I changed schools 5 times. So there wasn't much settlement there. One thing I found very helpful was the scouting movement. I joined that, and that was a common thread you could take from town to town. The last place that I lived in the country was Walker. I was just there for a year. My parents were there for several years. But I finished 6th grade there, and in Australia you went to high school after that. And the headmaster of the primary school and high school got together with my parents and decided Walker wasn't the place for me, and got me into a selective high school in Sydney. So I boarded in Sydney for a few years to go to Fort Street. And then my parents moved to Sydney eventually. But Fort Street was 6 years at the same school, so that was fairly consistent.
Yeah. And then I understand that through high school, you were one of the top students, and certainly in the statewide exam at the end of high school, and you were presented with the Gold Duke of Edinburgh Award by the late Prince Philip. How did those sort of achievements start to affect your future career and where you went from there?
Well, one of the agreements I had with my family, which all left school when they were 14 because they were children of the Depression, and nobody had gone to university, is that I had to pay for my final 2 years at school and for my university. So I won scholarships to finish the last 2 years of school, and I won an award with the Department of Works. They had cadetships, very prized because you got paid to go to university. The catch was you had to work for them for 4 years afterwards, so you're indentured. And they're very competitive, so marks certainly helped get into the interview, but what really got the interview, I think, was things I'd done in the scouting movement and with the Duke of Edinburgh Award. And so that launched me into a period of time where I got paid to go to university, and I worked the summers, so it was like a co-op program. And that was an amazing experience.
I bet it was. But then it would have been such a unique experience then afterwards to owe years of service and to do that back. What was that like to work as an engineer class 1, and how did that influence sort of what came next in your engineering career?
Well, I really should go back to the experience in the summers. And the first summer I was just done 2 courses in engineering. I'd done machine drawing and descriptive geometry, and a course in statics. And that year I was put in the structures section, and I was given a drawing board and a set of tools, because this is the days before AutoCAD, given some engineering sketches and was drawing them up. Did that for about 2 weeks and was getting rather bored, so I was a little impetuous. I went to my boss, who was a class 3 engineer, and said, "I'm a little bored, can't you give me something a little more challenging?" He looked at me. He didn't say a word. He turned around and went his back to his desk, and I thought, oh dear, I've done it this time. So I went back to the drawing board, sketched away. About half an hour later, he came back and laid on my table a set of architectural plans. And he said, "These are the architect's plans for the Peakhurst telephone exchange extension. Design it."
Wow.
Two-story reinforced concrete building. So I taught myself structural theory, and I taught myself how to do codes, and I designed it. He, of course, checked it very carefully, but I did design it. And the next year I was put in construction, and I got to supervise its construction. So that was pretty amazing.
Wow. Yeah, and all through, this is like in your summers through university.
Yeah, that's right.
Designing and constructing. Wow.
3 months at the summer of each year. I did aerodrome section was the next one. And the section that was beside that was investigations. And the chief engineer on investigations is obviously watching me, because he asked me to be assigned to his section when I graduated. So basically the day after I finished my exams, I reported for work in the investigation section with Bruce Rodway, who was a really incredible mentor.
Incredible. And even at your time, so you're doing all of this summer work and you're going through university, but you were the University Medal's top student. You first class honors, which I understand is essentially equivalent to doing a coursework master's here, the John Main Prize. And so you received a number of awards as you're going through this. It seems, you're doing things for the Association of Consulting Structural Engineers. You were designing in the summers, building. It's no surprise to everyone listening, like you were already then good at everything. So why did you then choose geotechnical engineering specifically when you went on to then pursue a PhD? What was it about geotech that drew you in?
Well, I could summarize that in one name, Harry Poulos. He was the lecturer in soil mechanics and foundation engineering. Amazing lecturer. And in addition to being an amazing lecturer, the topic was just so fascinating. There was so many variables, so many complications, that every project was a challenge, it seemed. And so that's why I decided I was particularly interested in geotechnical, which fitted well with me being put in the investigation section. So I had no intentions whatsoever of doing a PhD. I was indentured for 4 years, but Harry, who I did my final year thesis with, said, I'll apply for it. I said, what's the point? I can't do it. I'd have to pay back all this money. And he said, just apply. You can always say no. Okay, I'll apply. So I applied. And of course, got accepted. And Ted Davis, I guess, decided he was going to be my supervisor. And so he went and had a little word with Bruce Rodway, and they came to an agreement that I could do my PhD while working with the department. I was given 3 years less a day to do a PhD. No pressure.
No pressure.
And so that's when I really started my PhD with Ted Davis, about 3 months after I started working as a class 1. I still did some work for the department, but a lot of my time was really doing my PhD.
That's incredible. So some of the working day, you were able to do a little bit of your PhD work. But was that sort of when the early morning work ethic and sort of kicked in, or is that something that came later that we'll talk about a bit later?
Oh, no, that was definitely very long days, very long days. 3 years less a day. And actually, I did it in 2 years and 7 months, 8 months.
While working full time?
Well, not full time. Part of my full time work was doing my PhD, but it was an interesting experience.
So you did your PhD in less than 3 years, and yet I've seen your 2-volume PhD, which is, it is an impressive body of work. You're one of the first to model soil structure interactions with rigorous elastoplastic finite element analysis, and you were doing experiments to also validate theories, right? You have 2 papers with your supervisor, Professor Davies, 3 with John Booker, and 1 with Poulos himself. So you had 3 of Australia's leading geotechnical engineers working with you at the time. How did that come about?
Well, it evolved. Ted Davis was my principal supervisor. He went on sabbatical leave for a year. And those days, when you left from Australia. It wasn't quite as convenient as today. So I did have a year when he wasn't there. And that's when I particularly got to work with John and Harry, or started working with them, and continued as well after Ted came back. Ted was an interesting supervisor and I think an unsung hero. He only ever had 5 PhD students who finished. 4 of them have been Rankine Lecturers. That's a pretty amazing statistic. John Booker sadly died before he could give his lecture, but he'd been invited to give it. So there was Harry Poulos was the first, John was the second, myself, and John Carter was the 4th. So out of 5 students, he was very successful in picking people who in turn were very successful. One of the things I remember when about Ted, well, 2 things really. We used to meet when he was there every Monday morning from 9 till 12. And I thought this was going to be to talk about my PhD thesis. I don't think we spent more than 10 minutes talking about my PhD thesis, not all the time. But he'd sit there and he'd say, he was a pipe smoker, so he'd pull out his pipe and light it up and puff, puff, puff. And say, Kerry, I got this interesting consulting job. Let's talk about it. So we spent 3 hours talking about his consulting job, week in, week out. I was a little impatient, but nevertheless, it was interesting. And The other thing he said to me when I was leaving to go to Canada, and he wasn't very happy about that. I heard secondhand through John Booker that he said that he didn't like it because he didn't think he'd ever get me back. They'll never get him back, he said. But in my last meeting, he said, Kerry, I'm a gardener. I pick good seeds. I provide an environment for them to grow. It took me quite a long time to really appreciate what he was saying. It took me supervising many students, but I fully understood what he was saying. And I think he was a person who decided that I didn't need his help to get a PhD. He was going to train me as a consultant. And in retrospect, he did a darn good job of it. So I appreciate it a lot more today than I did during those 3 years. I learned a lot from Ted. Not necessarily what I thought I was going to learn from him, but I learned a great deal. And I certainly value the opportunities that I got because of him organising for me to do a PhD.
Yeah, it's amazing how sometimes the lessons you're learning from your mentors they come back to you later in life in a very different lens, and you start to see things in a very different way. And it sounds like, you yourself, it took some time with your own students before you could really understand his message of what he was trying to do with you. That's very powerful. So you were doing this, you were going in as a student, PhD student, spending hours with him, learning about consulting, as doing your PhD. So all of that's happening on your professional side. Let's maybe take a second and talk about what's going on in your personal side. You've had somebody with you this whole journey, and I'd love to hear a little bit about how you met your wife and how sort of all came to be.
Well, I mentioned before that I was, as a kid, involved with scouting, and I continued to be involved with that. I was a cub leader, a scout leader, and ultimately, with my wife, a venture leader. And she was a guide leader. And we actually met on a scout guide camp. And that's where we first met up. And she was also going to the University of Sydney. She was doing a Bachelor of Arts. And so we were at the same institution. And obviously had a chance to meet up there. I actually ended up tutoring her in general math, which was a first year course that I had some money from tutoring for. And she helped me with typing up punch cards for my computer science degree. And so once we both graduated, we both were paid as full-time public servants. She was a teacher. I was being paid as a graduated student, even though I was still a student. So we got married in May of 1971. So we were 21 at the time.
Incredible.
Been married for 53 years now.
That's amazing, Kerry. And clearly, nobody is successful without the team around them. And I know how important she has been throughout your entire journey. And together you've raised a beautiful family. I mean, well, I'm sure we'll come back to it, but I'd love to hear a little bit about the family you have and your children and grandchildren.
Well, I have 3 children. The first was born in Canada in 1982. And then the second, who's 3 years younger, was born while we were on sabbatical leave in Sydney. So he was actually born Australian. We had to apply for a visa to get him to come back to Canada. And the third one was born in 1991. And he's also born in Canada. So 3 children, 10-year gap between them. So the first one we were 30, then the last one we were 40. Then the eldest one's got 3 children, ages, well, one will be 13 in a week or two's time, 10 and 8. And the youngest son has got a little boy who walked for the first time 2 days ago and is 1 year old.
Incredible. Well, that's amazing. So, and I can imagine that your middle son sort of probably has had moments in life lording over his siblings that he's in fact Australian, like mom and dad, but they're not.
Yeah,
So yeah,
yeah.
as siblings would. And so I know that your grandchildren have really like been a huge part of your life. And I remember there were stories that you were talking about. So you had at your property in Godfrey, there was a large pile of sand or something delivered for some reason. And I remember you saying that this was the best, playground possible because you were out there and your grandchildren were getting like the most in-depth lesson on how a bulldozer can actually move across this sand pile and design and build. And I had a moment thinking they probably just want to like build a sandcastle, but they are getting a really good lesson.
Yes, well, it's grown. I think we have now 3 truckloads of sand. So it's got a big pile and lots of tunneling, lots of dams, lots of castles, lots of earthquakes. Quite a little challenge. And in fact, on one of my court cases, I built a little model with my eldest grandson, videotaped it and used it for the court case to try and illustrate to the judge the mechanisms involved, and so you could visualize them. So they're quite budding young engineers, except for the 1-year-old. He hasn't quite got the grips of it yet, but all the rest of them have.
But if he's walking at 1, he's already an overachiever like the rest. None of the apples sound like they've fallen far from the tree, that's for sure.
Yeah.
Okay, so your eldest was born in Canada, but up till now we've been talking and hearing about sort of your career in life in Australia. So let's talk about what brought you to Canada, and how did joining the University of Western sort of shape your career and when you arrived in 1978 until you left?
Yes, well, it certainly wasn't in my planning. I was after I finished my PhD, I went back to full-time work with the department, but you have to understand it was a government department that was highly unionized. And so one was only allowed to work 35 hours a week. And I'd been quite used to doing closer to 100 hours a week instead of 35 to get my PhD done. And so I would be finishing off my duties fairly early in the week. And one of my duties was supervising some experimental research, both laboratory and field. We were doing at the University of Sydney on socketed piles. And so I would go into the university when I was not allowed to work at work and do the theoretical modelling to match up the experimental work that was going on. So I was still keeping quite active in research, even though I was not strictly speaking required to do that. And one day, Harry Poulos came in where I was sitting at a desk doing some computing. And he said, I've just come back from sabbatical at the University of Western Ontario. And they've been looking for somebody like you for the last 4 years and haven't been able to find one, basically a modeler. He said, why don't you apply? I'm sure you'll get it. And then we'll hire you back here in 3 years' time with the international experience. I thought that sounded pretty interesting. So I went home and spoke to my wife and said, well, what do you think? We were still pretty young, mid-20s. And I was commuting over an hour, sometimes an hour and a half into the centre of Sydney to work. She was commuting half an hour in the opposite direction to teach at a very large high school in a challenged area, shall we say. Okay. She was a history teacher, but was mostly teaching them how to fill out unemployment forms. And just to give you a sense of what the school was like, when she told the class that she was going to be leaving them to go to Canada, one of the students said, Miss, what are you going to do with your car? I said, oh, we'll just sell it. Oh, Miss, don't do that. We'll burn it out for you. You'll get more money on the insurance.
Oh, boy.
We didn't take him up on his very kind offer, but it gave you a sense of why teaching history wasn't actually number one in the interest of students at that school. So she was quite interested in a change. So we applied for the job. I got a phone call at 3 a.m. from Professor Barry Vickery, who had been a professor at Sydney and knew me as an undergraduate. And then he'd gone to Western to work in the wind tunnel lab. So he was calling me to convince me that I should accept the job. I do remember him telling me how cheap beer was in Canada at the time. And so accepted, and we arrived in London, Ontario on the 8th of December, 1978, to be met by Bob Quigley and Barry Vickery, who the day before fallen and broken his arm on the ice. So welcome to Canada. But, we stayed with the Vickerys for about 2 weeks until we bought a house, and I really got settled into things at Western very quickly. I had gone there particularly because I wanted to work with K.Y. Lowe, very well known for his work on soft ground in particular, difficult soils. And I worked with K.Y. for the best part of 30 years on different jobs, consulting jobs, a lot of tunneling work I did with him. So that was a great experience. Then Bob Quigley was, at that time, a bit of a pioneer in looking at the movement of chemicals into the soil from landfill sites, and he was keen to have me help with the modelling of that. So that's where I got into the start of what we now call geoenvironmental engineering. And the other trigger there was I arrived just after President Carter declared the first state of emergency at Love Canal, which of the first of the Superfund sites, and only an hour and a half's drive from Kingston, from London. And so I started thinking, what can we do better? So those were when I really got started in tunneling research and in geoenvironmental. But I was still continuing some of the stuff from my PhD to get that finished. And I also brought with me the rock-socketed work. We'd pretty well solved the problem in Sydney and applied it to Melbourne as well with the soft rocks in those two cities. But I was interested to see how it worked in Canada, so I was able to get a grant from Public Works Canada to allow me to take a lot of data that had been collected by others and to put it with the theoretical framework and just show that they worked, whether it was soft rock in Sydney or Melbourne or in Burlington or wherever. So I finished that work in about 85. I think I decided I solved the problem and moved on to other things.
Kerry, I mean, we could spend a lot of time talking about your transition and welcome to Canada being in the middle of winter and how that sounds like it was, a crash course in what Canadian winters can be like. But what really stands out is you just talking about the breadth of topics that you spent time in. And I mean, the list is quite extensive. You talk about anchor behavior, piles and soft rocks, soft ground tunneling, reinforced embankments, geosynthetics, engineering in challenging climates like Arctic, Antarctica. I mean, I'd love to hear about each of those, but I'll let you sort of decide if there's one or two more that we haven't heard much. But you're excellent in everything in high school, and here you are again being excellent in every single topic you're picking. How did sort of one of those rise to the top in the end? And yeah, I have some follow-ups, but maybe I'll start with there. Like, is there more on any of those you want to address? Or,
well, I think with Ted Davis again, because one of the bits of advice he gave me, there wasn't much, as I said, was that when you're doing a parametric study, put yourself to the practical range. I was a fairly focused person and like to keep things practical. He said, just explore, because you never know how somebody else might use your solutions. And I followed that advice, and I discovered later that my anchor work was mostly used for submerged pipelines. Something I never thought about it being used for, but apparently it worked very well for looking at the performance of submerged pipelines. So I really carried that message with me for the rest of my career, and often telling students that little story. when they want to be a little constrained. So that was a good bit of advice. The rock socketed I'd been working on for quite a few years and finished that off with about 5 or 6 years in Canada because I get bored quickly and I don't like doing things just to add a little dot here or cross another T. I solve the problem, I solve the problem, I want to move on. So I've always been looking for what's the next problem I want to tackle. And so I could continue on finishing off the anchor work, which I'd done in the early 80s, I'd finished, and didn't publish it after that as far as I was concerned. It was done. I finished the work I was doing on socketed piles in the mid-80s. But I started with the Geoenvironmental. I started with the tunneling, which I carried on for a couple of decades. And I also had an opportunity. I was approached by the Department of Transport in Ontario because around 1980, they'd been approached about this wonderful material called geotextile. And it would allow them to build roads that they couldn't previously build on very soft foundations. And so they wanted to try it out on building an embankment on about 8 meters of peat, up to 8 meters of peat, and Bloomington Side Road. And they asked if I would be interested in being involved in the monitoring of it, analysing it, and developing some design guidelines. And so 2 things were very new to me, geotextiles and peat. The modelling part I knew how to do, but these were 2 materials I'd never dealt with before. And I assumed initially that, oh, geotextiles, there's got to be a lot of work done on that. So I started going to literature and discovered very little had been done on that. There weren't any standard test methods. So I then spent 20 years working on standards development for test methods for geosynthetics and understanding how different geotextiles behave, particularly their stress strain behavior initially, subsequently their behavior for lining systems. And peat, I thought, there's so much peat in Canada, people have surely got to understand peat. So I pulled out a few papers and I noticed that people were quoting friction angles of 50 to 60 degrees. And I looked at the material and I thought, something's wrong. I look again at the tests and they were doing triaxial compression tests. But they were simply stopping the test when the specimen was so compressed that you couldn't do the test anymore, and then drawing a circle and getting a big friction angle. So I started developing, in fact, using the Norwegian simple shear device to get friction angles of about 26 or 27 degrees. And in parallel, and I didn't know it at the time, we both started publishing about the same time. Arvid Landver out at University of New Brunswick was using a ring shear apparatus to do the same thing. And we came up with very similar friction angles, which gave us a fair bit of confidence. And so once I started putting those into the model started making sense. And we developed design guidelines, instrumented some more embankments, and tested it with both peat and with very soft soil that had a shear strength of maybe 1 or 2 kilopascals below the peat, because it never really had any stress to consolidate it. And developed design methods that have been extensively used since then for embankments on peats. That got me interested in soft clays. I did work with the Gloucester fill, and that also got me interested in what I would call rate-sensitive soils. You could argue that all soils are rate-sensitive, but in particular, I was interested in the soils, and it's about 30% of the soils in Canada fit in this category, where they don't follow traditional soil mechanics. Terzaghi would say that once you load it up, you reaches your peak load, your peak pore pressures, and then it consolidates and the pore pressures dissipate. On these soils, you finish your loading and your pore pressures keep increasing, and failures can occur weeks or months after the end of construction. And this has been a bit of a problem out in New Brunswick. So getting together with Arvid Landver and Arun Valsanka, who are both out there, we got a grant to build and monitor a test embankment out in Sackville, and built one reinforced, one unreinforced. And so I spent a fair bit of a sabbatical leave constructing that embankment and then subsequently modelling it. So that was very interesting work. Follow that up by doing stuff with piles, foundations, and reinforcement.
Kerry, it's one of the things that's really interesting about the work you've done is you really have always focused on sort of the experiments feeding and helping to validate and understand the models. And that's something that not everyone does. Often somebody will focus on just doing laboratory work or experiments or numerical modeling. And you really have sort of done significant body of work in all those three things. How important is it to you when you're looking at whatever project it is, and to have all of those three components as part of it? Because in all of the work you've spoken about so far, sort of each piece sort of plays an integrated role.
Well, again, I come back to my time at Sydney, firstly doing my undergraduate thesis with Harry Poulos, which involved experimental work, because Harry was a great one for doing experiments to work with his theoretical solutions. And then when I started doing my PhD, I was intending to be a pure theoretician. But I very quickly discovered that most experimentalists don't know what to measure. They do what they can do because they can do it. They don't think about what the modeler is going to need to actually be able to model an experiment. And often critical parameters are never measured. And so that's why you see in my PhD thesis quite a lot of experimental work, because I couldn't find enough good quality work in the literature that I could really test out the theory. So I began doing my experiments myself, using what were really early models of our geosynthetic liner longevity simulators today. And that really taught me that if you're going to do theory, you really need to have experiments to get the parameters, and you need field work to test the theory really works. So as a theoretician, I spend about 95% of my time getting experimental data and field data, because the theory is the easy bit. It's getting to work in practice. That is the challenging bit.
No, I think that's such valuable information and advice, because so often now I feel people really do try and silo themselves into only one area. And you're right, it's so important to have that breadth and do all of them. Okay, so we focused quite a bit so far on sort of the research and some of that aspect at Western. I'm wondering if we can take a step sort of to the other areas that are part of being, a professor at a university and in your teaching and your lecturing style. I mean, you've won multiple teaching awards. You're an exceptional teacher. From experience, I can say that, and I know all of your undergraduates and graduate students would say the same thing. How did you develop that as a young professor at the University of Western Ontario?
That was quite a challenge, because I'm not by nature a public speaker. I had to teach myself and how to lecture. And I've always been a good observer. So I watch lots of things. I look for patterns. And the first pattern I noticed was reflecting on my own experiences. So what did a good lecturer do to make them a good lecturer? What did somebody do that didn't make them a good lecturer? And I thought, okay, I can learn from both. I try to avoid doing the things that do not go well in a lecture, and I will try and emulate those things that do go well and my role model, first and foremost, was Harry Poulos. But then as I got to see other people, particularly at conferences and that, one person that really impressed me when I was a graduate student was Peter Rowe. He spent time on a sabbatical at Sydney while I was a PhD student. And so I got to attend some of his lectures on cam clay. And it just struck me that he had a really good lecturing style. And then going to conferences and listening to what I'd call great keynote lecturers and not so great keynote lecturers. And some of the great ones, that I can think of, other than Harry and Peter Rowe that I just mentioned, was Wayne Clough, Mike Duncan, were two people I was very impressed at how they presented lectures. And I would try and learn from what they did well and emulate that and try and avoid the pitfalls. And really it was a trial and error process, but just by watching what people do well, you can learn a lot.
Well, and I mean, clearly you've learned and do it well. You've been invited to give some of the most prestigious geotechnical lectures. And I think there's some stats about your sort of being one of only 4 Canadians and 2 Australians out of a total of 11 people to give both the Rankine and Terzaghi lectures. So it's clearly you have honed this craft very well. And it's a surprise to me that it doesn't come naturally to you, because you do come across, whether you're giving one of these prestigious lectures to just teaching in an undergraduate class, sort of, I've seen the gambit and you seem very natural. So you really learned that well. That's impressive. But
I'm an actor.
Okay, so that's sort of, we've talked about the research side, we've talked about teaching, but there's this whole other part about service. And you actually ran for the head of department when you were, in your mid-30s. So having a young family in Canada just after being promoted to full professor, when most of the rest of the department at the time was in their mid-50s. How did that work out for you? And what did you learn from that?
Well, you'll recall I mentioned before 2 things. One, I can be a bit impetuous, and running for head of department at that stage was a little impetuous. But also, I was uncomfortable because everybody was comfortable and doing the same things. And those days, most professors disappeared in the summer and went to their cottage, and I'd be one of the few people who's still there all summer, which meant I got a lot of secretarial help. But I was worried about our students because we, in civil, go through periods of increase and interest and loss of interest, and our program wasn't attracting students. And it hadn't been really looked at carefully for many years. And I was very keen on really revamping the curriculum. But I learned something about university politics, and that is that decisions are usually made before you get to a meeting, not in the meeting. And that if you want an outcome to be favourable, you have to do a lot of politicking before you get to that point. And so in that case, I hadn't, and there were 7 people on the committee. I got the votes of the provost, the VP research, and the dean, and none of the 4 faculty members who were not so enthused about my ideas for changes. But what happened as a result of that is the appointment was made for 3 instead of 5 years to the successful candidate. It was very good, but just comfortable. And I was appointed as the first Associate Dean, Research and Graduate Studies for the faculty. And then 3 years later, I was appointed unopposed. So I completely revamped the curriculum, but mind you, I'd learnt to do some homework and get critical people on side, in particular Alan Davenport, who was the superstar of civil engineering in those days, wind tunnel expert. And with his support, I managed to get quite a lot of changes to the curriculum, and hired a lot of professors start retiring, and so hired a lot of young professors. So it was an interesting experience.
It sounds like lots of lessons learned, sort of especially in how sort of governance and sort of as you move up in a university, how those things play out in the sort of interworking in politics. Because then you go on to be elected as the third president of the International Geosynthetics Society, still before you're 40. Then you become president of the Canadian Geotechnical Society, president of the Engineering Institute of Canada. You have 18 years as an academic administrator, and before you turned 50, you then became the VP Research at Queen's, a position you held for 2 terms, so 10 years. How are you drawn to fill these positions, and sort of what from your sort of initial time as head of the department sort of led into these pieces, and well, yeah, what drew you to do those roles?
I think it's more or less the same thing. I do get restless. And once I've got something working well, I start to wonder about what can I do that's a bit more interesting. And when I got involved with geosynthetics, I was at the first meeting where discussion of the founding of the society was discussed in 1982 in Las Vegas. And I got interested in what was happening. The first president was pretty titular, didn't do very much, but there was a very active vice president, J.P. Guru, who did a lot of the work, and then he became the second president. And he did a fantastic job of getting the society launched, getting all the bylaws ready and all that really critical stuff to get a society going. And I saw my role as potentially outreach and broadening the society, getting it to grow. And so I did 4 years of, as president, focusing on that activity and trying to take the society from a really excellent start, which JP had produced, to the next place. So that was really a motivating force there. As I said, the motivating force for department head was to really revamp the curriculum, which after I did it, a lot of other universities copied. Some of the things I did. I did things people said you couldn't possibly do, and still run a civil department and get accreditation, and did it. Because we had a small department. You know, if you've got 50 professors, you can do a lot of things. If you've got a small department, to be good, you've got to focus. And so I really focused the department there. Queen's followed before I ever got here. Followed the same model because, again, it was a small department. But, you know, striving to make change, I think, would be the underlying effect. Coming to Queen's was a little bit different. I was comfortable by the time I was approached. I didn't apply for it. The headhunter came and asked me if I'd come for an interview. I did, and probably it was good that I didn't really care whether I got the job or not, because you're much more relaxed when you don't care than if you're too stressed out. Then I got offered the job, and I pondered it, and interestingly, I left it. I was given 2 weeks to make a decision, and I was coming up on the 2 weeks, the Friday night before I had to give an answer on the following Saturday. I had dinner with 2 friends, Sue and Ian Moore, who you know, and Sue was convincing me I should go, and Ian was convincing me I shouldn't. He didn't want me leaving. And so I went to bed that night, not knowing what I was going to do the next day. I had to get up at 3 o'clock because I had a grant application I had to finish, and I was flying to France later in the day.
As you would be, classic Kerry.
Yeah, as I do. So I was sitting there thinking about it as I'm writing up this grant. At 9 o'clock, I had to call Bill Leggett and tell him whether I was going to accept or not. And I called him up and said, well, I'm sorry, but I don't think I'm going to take it. He said, why? He said, because I'm not prepared to give up on my research. He said, that's precisely why I want you. I want somebody who leads by example. got a $100,000 insert grant. I want 2 of us who are active researchers. So I said, I'll sign on the dotted line. It actually was sent to France. I signed it in Paris.
Amazing.
And that's how I came to be at Queen's. Again, the conversation was obviously longer than I just reported it, because he talked about the things he wanted me to do, and I talked about the things I needed to do, and we came to an agreement on those things. And one of them was being able to build up geotechnical engineering here in Kingston. So that was one of the challenges. As I said to a few people at the time, there was nothing here but opportunity.
Yeah.
Richard was at a Royal Military College, and that was part of the opportunity. By linking the two, which we did, and very successfully, and you're part of that. But one of the good things the dean at the time had done, a very, very good dean, Tom Harris was his name, is his name. He's now retired. But he told the department that if you get somebody I don't like, I'll take away your position. If you can't hire someone, I'll let you keep the position till you can find somebody I like, which meant there were a number of vacant positions when I got here. And the dean also was helpful, because at that time Ian Moore was acting dean at Western from that position. And Tom recruited him as a Canada Research Chair. So that gave 2 established people in the department. And then Richard Brackman was hired from University of Alberta, and we got, between the 3 of us, a large CFI grant, which allowed us to build new facilities. And then that attracted Andy Take from Cambridge. And then we got Greg at RMC, subsequently yourself. And I'd also been trying to hire, when I was at Western, Gene Hutchinson and Mark Diederich. Gene had a position at Waterloo, but Mark didn't have a position. He was acting as a consultant. And I was trying to organise to get the 2 of them to build up the Geo group at Western, and that fell through, of course, because I moved. But I negotiated with Bill Leggett a couple of positions that could be filled if all the usual union requirements were met. And ultimately, both of them joined the Geological Engineering department here at Queen's to help build up the overall Geo group. And Ian did all the heavy lifting to start the Geoengineering Centre at Queen's RMC. It was the first joint graduate program to be developed between 2 institutions. And the rest is history. We've got over 22 Geo professors now.
It is an incredible sort of legacy that you and Ian and Richard Bathurst have built together, as like in hiring and sort of creating this powerhouse at Queen's. And but even just jumping back, it's really powerful, Kerry, to hear you talk about, you chose roles based on, not just because they were there and available, because you really wanted to bring change and make an impact and sort of drive that. So when you're talking about the different positions, it sounds like for each one you had a reason and a motivation of something tangible you wanted to do. And coming to Queen's, I mean, you're taking a step, right? You're leaving a powerhouse of geotechnical engineering at Western to move to Queen's and take on a very important role of VPR. And it sounds like you've achieved quite a lot in that role, sort of developing the Geoengineering Centre. But maybe a huge part of also sort of in both, whether it's Western or Queen's, a huge impact that you've had is really your graduate students and sort of the legacy that continues to grow through each and every one of them. So, I mean, you've had many graduate students in your time, and clearly we don't have the time to talk about all of them and sort of their research and interests and what they brought to you, but I'm hoping you can reflect a little bit on the pleasures and probably challenges of supervising so many students.
Well, I think it was in the early numbers rather than the 100 plus that I really got to experience the fact that everybody's different. Every student is different. And I think this is partly what Ted was trying to say, Ted Davis, with his gardening analogy, is you look at the student and you need to decide what's the best for them, depending on their personality, their skill set, their abilities. And that it's not one rule that fits all, but you need to look at each student as an individual and provide the development that they need to be successful. And that can vary enormously depending on the individual and their abilities and their experience. You get students who go straight on through, and I've had a lot of students who come back. They've been out and worked for a few years and decided that, you know, there's a glass ceiling there. And if they want to go to the more interesting work, they need to get a master's often, and frequently that converted into a PhD. And so learning that they're all different, and the way you have to manage them fits the individual. So sometimes it's just supportive, sometimes it's being quite strict. It's a matter of what's going to be best for the student. But I have the view that the greatest legacy that we ever have as a professor is not the papers we write, it's the students and the people we train and what they go and do. And I think that is really important, and certainly something I've dedicated myself to. Even with a large number of students, I do not use postdoctoral fellows as quasi supervisors, as many professors do when they've had a fair number of students. I try and provide the guidance myself on my own, but of course that varies with each student, and it depends where the student is in the process, whether at the beginning, the middle, or till the end. All different periods in the life of the student and the experience of the supervisor. So that's good. And of course, I take great pride in the success of my students and winning awards and themselves and being very successful in business. And now I have to say some of them are retired, while I still am not. But yeah, mentoring to me is the most important thing you do as a supervisor. And I was really fortunate to have outstanding mentoring. Mentoring initially from Harry Poulos, then from my Bruce, who was my supervisor at the Department of Works or Construction or Housing Construction. It's changed its name 3 times in the 8 years I worked with them. But Bruce Rodway was a wonderful advisor. And then John Booker became a very close personal friend. He did several sabbaticals with me at Western, and I did sabbaticals with him at Sydney, and we worked until actually our last paper was published after he passed away, and our book was published after he passed away. So that was a very, very fruitful relationship. And Ted Davis gave me great mentoring. I didn't fully appreciate it until after I left, but I very much appreciate it now. And when I look at the success of his 4 of his 5 PhD students, it's pretty remarkable what he has achieved. And so to me, mentoring is important. When I was head of department, I did a lot of mentoring of the new faculty I hired. I actually had formal mentoring sessions with them as a group as well as individually. And here at Queen's, we've just hired a whole lot of new people, and I've self-appointed myself as the mentor for those people to try and help them develop. And when my students leave here, they ask me, what should I look for in a job? My answer is good mentorship. More important than how much you get paid, more important than where you go. You want somebody who's going to help you develop your career as an engineer. So to me, that's all important.
Yeah. Yeah, and I mean, you speak like so eloquently and with such gratitude to your mentors and sort of the lessons that they've taught you over the years. Maybe I'll flip the switch a little. What do you hope your students, what are some of the key things that you hope you've imparted to your students? So someday you're going to have a student doing a GeoLegend and they're going to talk about sort of the mentorship that they receive from you. If you could pick a couple of things that you hope you're really imparting to them, what would that be?
Well, first would be a bit of advice I got from John Booker when I arrived here and was dead scared of student ratings and what that might do to my career. And he said to me, the most important thing is that you really care. Students can tell if you really care. And if they sense that you're doing your best, they'll be much more forgiving than if you are not. It's not that you have to be perfect. It's got to be you really care about what you're doing and you're doing your best. And I found that's really good advice I followed for the rest of my career. And another really old adage, but one bit of advice Bruce Rodway gave me when I started with him. And I don't think it's original, but it was original to me at the time. You can do 100 things, 99 of them well and one badly, and everybody remembers the one thing you did badly.
Mm. Yeah.
The other bit of advice he gave me is very shortly after I started was, well, you got A's in all your courses. High distinction was the term he used there, but now you have to get a high distinction in man management. He gave me a brand new Maynard pressure meter, a manual, and assigned a drill rig and a couple of drillers to me and said, go out and get me some results. With a bunch of drillers who I'd never used the equipment before. I had to spend a weekend studying it. And drillers who, to me, were old at the time. I have to tell you, my definition of old is 10 years older than I am at any one point in time. When I was 5, it was 15. When I was 15, it was 25. So it's a moving target. They were in their 40s and I was in my mid-20s, so they were old. Mm-hmm. And they were used to drilling the good old-fashioned way. And getting an A in man management, as Bruce referred to it, was being able to convince these ornery old drillers that you could do something different. And people management is a really important part of an academic's life, as it is in most aspects of most careers. Knowing how to appreciate people's strengths and weaknesses, how to help them develop is, I think, an important skill that I think I learned by watching other people, Bruce in particular, who was brilliant at it. Just seeing how you deal with situations, how being calm is a very useful thing. Not raising your voice is a useful thing. Doing your homework is always a useful thing. Understanding where people are coming from, what their backgrounds are. Those are all very valuable things to learn. And, one of the greatest rewards you get as a professor, and this happens every now and then, I get a letter unsolicited from somebody who graduated 5, 10, 15, one case 30 years ago, saying, thank you. I still am using the lessons that I learned, and that's when you really feel you made a difference. And although I've had a large number of students, I've still got contact with about 90% of them.
Yeah, and Kerry, that doesn't surprise me because of, the mentorship and the supervision you've provided, and having experienced that myself. I mean, when you talk about the advice and sort of what you hope we take out of it, it certainly is those things. You talking about caring and showing up and being there. I remember as a first year master's student being terrified. I was going to the VPR's office on a weekly basis to have our research meetings, but you made time. I was such a small piece of your overall research, but it was just as important to have those, to show that what I was doing was mattered to you. So you really do impact and sort of have had that lasting impact on all your students. So I'm not surprised that you're still in touch with most of them. That's a testament to you and the leadership and supervision you've shown all of us. Absolutely.
Yeah. And one of the things I'm proud of my time as VP here is that 15 years later, I've still people come out to me thanking me for help I gave them a long time ago. That was a really good experience. I enjoyed that. That was a fascinating job.
Yeah. And maybe I have a couple of extra tangents I'd love to keep going on. And so I might, though, just say sort of, you've done a significant amount of teaching and research, and you also had this whole piece that you were doing, which was consulting and sort of offering your expert advice. How have you found trying to integrate all of that, and sort of how does that come together for yourself, your career, your students?
I think I could summarize it by saying the secret to success is double or triple counting. If I've always tried to make sure that if I'm doing consulting, it's an interesting problem. And I don't sit at bed at night dreaming up my research projects. They come to me through consulting. And you're working on a project, and I only consult for consultants. I don't do anything routine. It's only work that the consultant needs help with. And so it tends to be the more challenging problems. And I find myself, saying, okay, well, I can give you a consulting answer, but this really needs a PhD or 2 or 3 to answer it. And that launches me onto a research project. And often I can leverage funding from my client with government funds to a research project we're involved with on the periphery of when we built our first full-scale field site, which was to explore the performance of geosynthetics in field situations and see how they compared with laboratory behavior and why some things were failing in the field and some were not. And so we built in 2006 the first full-scale test embankment that allowed us to discover all sorts of new things that you'd never discover in the lab or lying in bed at night dreaming about them. But we discovered had been noted in the field. They just hadn't realized what they were seeing. When you went back and looked at papers and things they were reporting, they were misunderstanding what was happening, but it was happening. And so what I've been able to do is to tie in my research with my consulting and also my teaching, because I teach an undergraduate design course, environmental design. Well, PFAS came along. I've been doing work on it for almost a decade, but people didn't start worrying about it until a few years ago. I designed the first part of the Holton landfill back in 1990. Last year, I designed cell 4. And this time I had to design it for PFAS. And we used the research we developed over the last decade in developing that design, and we're constructing it at the moment. We've got 2/3 of it constructed last year. We'll finish the last third next summer. And I'm incorporating that in my undergraduate course last year. So as it's happening, the students are learning about it. I teach a graduate course on barrier system where I'm including all of that sort of information. It changes every time I teach it. And a course in human factors and engineering failures, which builds along all of the forensic work that I've done over the decades and tries to teach students that failures don't occur because we don't know what we should do. Failures mostly occur because people didn't do what they should do. And there's human factors, and invariably at least 3 human factors seem to come into play before a really nasty thing starts to happen.
Wow. Yeah, it is pretty powerful that you're able to bring that into the classroom and share that and sort of have even a wider a wider impact when you're getting into the undergraduate and graduate courses and not just the graduate students you're supervising, and bringing those all together. So I guess sort of that's a significant portion, and sort of talking about sort of your research and teaching and integrating those in consulting. What are you excited about in terms of what's coming next? So, you know, you talk about sort of you're always intrigued by the next question and sort of the research. So I'd love to hear sort of what it is that you're still hoping to check off, because you're, you know, in the office right now working and still at it.
Well, as I said, you've got to be looking well ahead. You don't suddenly get people who want to pour money into your research project because you've got a good idea. You need to have enough background behind you. You can convince them that they need to pour some money into it. So about 10 years ago, maybe even a little longer, I was doing a review for the state of Victoria on a proposed site for disposal of PFAS contaminated waste. And really, the outskirts of Melbourne is where one of the most tragic cases of PFAS have occurred. Dozens of people have died as a result of PFAS contamination, and many more with cancers. But that got me interested, and of course I realized there's basically no research in our geoenvironmental field on it, so I started work on that, which nobody was very interested in for quite a time, but now is a hot topic. So that's keeping me very busy. The other is mining. Mines were not particularly interested in containment facilities. Mineral extraction brings in money. Waste disposal costs money. But I figured that the time was going to come when they really did have to know about how geosynthetics could be useful in controlling mine waste, and both as underliners and as covers. And we have, 15 years now, I think, work on that. Fadi Abdulal, who's our colleague here, was my first PhD student on mining applications. He's now associate professor. That gives you a sense of the passage of time. But we're just so busy. There are so many projects, and just keep discovering new things. Just no shortage of new avenues to explore, because it is a big industry, complex industry, and so many fascinating problems that's keeping me busy, and probably will for the next half decade or so. I was launching into old dams. I do quite a lot of work on dams for the last 20 years. And it's very evident that a lot of the dams were built in the 40s, late 40s, 50s and 60s. And I gave a talk to the Hellenic Geotechnical Society about a year ago on old dams. And I define old dams that basically ones built since I was born, which is a large number of the dams. And those dams, many were built without modern understanding of soil mechanics. And they are aging just as we age. And it's quite a challenge dealing with some of those things. And I've got quite a lot of research ideas I wanted to pursue there, but I just got so overwhelmed with PFAS and mining, I haven't had a chance to pursue it. But if I had more time, that's what I'd be pursuing. I think there's a lot of really interesting research questions related to old dams. Mind you, Athens was not the ideal place to talk about old dams being 75 years old. As one gentleman reminded me afterwards, Kerry, here we say an old dam is about 4,000 years old.
Yeah, age is relative for structures.
Absolutely.
Yeah. So it's I guess maybe a little bit sort of on a tangent to some of these things. So it's pretty impressive. You've got ideas still coming at you, and not enough time to even address those that are still of interest. And You know, you're going to turn 75, if I'm allowed to announce your age, on the opening day of the 13th International Conference on Geosynthetics in Montreal in September. Yet you say you're as busy as ever. You're still a full-time professor. You're teaching undergraduate environmental design courses. You talked about your 2 graduate courses. You've still got upwards of 20 graduate students you're supervising, and we can hear from you and understand how much time and that involves. You're generating funding. I mean, it sounds like the questions are still driving you, but in general, what is driving you? And I'm sure Kath would love me to ask, when do you see retirement ahead?
That's a question I get asked very often. I remember John Berlin, who just turned 90, being asked that once, and his quote was, "When you love what you do, why would you stop?" So I think I will continue to be solving puzzles, because that's what I'm doing. I like solving puzzles, and there's no shortage of puzzles to be solved. And whether I'll retire from the university, that's another question. I will see. I've just taken on last September a number of new PhD students. I'll see them through, but I'm not sure I'll take on any more sole supervised new students. So I'll wait and see. I've been saying I'm going to do that for the last 5 years. So the proof will be in my doing, not in my saying. But unfortunately, one does get older as you get older. And there's nothing I can do about that side of it. But I don't think I will be retiring. If I retire, it'll be from the number of hours I put in today to a fewer number of hours, but not 0 hours. Because as John Berlin said, if you love what you do, why would you stop? And I look at other people around, like Harry Poulos, Cara Herg, Nordy Morgenstern, who are still doing interesting things, not necessarily the same level of research, and sooner or later I'll have to slow down on that. But there are a lot of people who kept on doing interesting things way after an official retirement day.
Yeah, and you certainly do clearly love what you do, so that makes a lot of sense that it's not something you're ready or want to stop yet.
Yeah.
So you've talked and had some incredible mentors and exposure to, geotechnical legends in and of themselves. I would say that coming up through the Geoengineering Center myself, I sort of thought Kingston was the epicenter of Geo-Legends. You've got yourself and Richard Bathurst, Ian Moore, to name just a few. If you had to have a dinner party, Kerry, and you were able to invite whatever number you wanted of Geo-Legends to the dinner party, who would you invite? But maybe more importantly, I'm wondering what you would want to be asking them and peppering them about. So who do you have some burning questions that you would love to invite? And this can be, we can play the dead or alive, who's coming to your dinner party. But I'm interested on probably just whose brain would you love to just sit and have an evening to talk and discuss about geotechnical engineering?
Well, obviously the answer needs to be people I've known.
Yeah.
Not necessarily known well, but have known. So, who wouldn't want to sit down and talk to Terzaghi? But that doesn't really count. Peck, I knew. That he would. I think I could count him. So, I really hesitate to put out names because there are so many of them.
And you don't have to, even just what is a conversation that you would love to have around the table of a group of geotechnical legends?
Well, I think what are your greatest challenges? What were the things that really pushed you hard? How much you had to persevere, because people don't always pick up on what you're trying to do, particularly when you're pioneering a new area. Obviously, the Terzaghis and the Pecks were pioneers from the very beginning. But then you've got Norty Morgenstern, and look what he did, the amazing things he did at the University of Alberta, starting off a whole bunch of new areas really important to Canada. You look at people like that who really make a big difference in the directions of research. And, Jim Mitchell's another example of that, for example, who passed away recently. The whole group of people at Berkeley, I didn't know Harry Seed personally, but people who went through that, like Mike Duncan, Wayne Clough, Paul Lardy. I have a lot of respect for Paul and some of the work he did. They're all really good people. The bunch of people in the UK, of course, done some really fabulous work. I have the pleasure of working with Cara Herg still today and Suzanne Lacasse, and working with them on dams. That's a really useful experience because they've got such a breadth of knowledge. Yeah. And of course, my old Sydney mates. If John was still here, it's such a shame that he died. Bob Quigley also died very young. A great loss there. Kuan Yi Lo, I learned a huge amount from working with Kuan Yi. There's all of the Ted, Harry, John from Sydney, all excellent people. Some of my contemporaries, John Carter, Mark Randolph, Scott Sloan, all good friends who we've all done interesting and different things. And so it's really hard to get a small group of people, as there are so many really good people. And I'm sure I will finish this and say, oh, I forgot X and I forgot Y. I should have mentioned them. Forgive me if I didn't mention you.
Kerry, it speaks volumes that you can sit here and, I've thrown a question at you that I didn't give you a heads up on, and you've been able to just name so many incredible people in their own right who have all meant something to you. And it is just because you also mean this to all of them and to all of your students and your colleagues. And it's one of those things that the legacy you've developed and are not leaving, because you're not going anywhere, you're still developing and creating, is so powerful and has been so impactful to so many. Not to mention the betterment of geotechnical engineering and environmental engineering in and of itself. It really is powerful. So yeah, I think as a former student of yours and a current colleague, I can extend that you really are a geo-legend and are and continue to have an impact on all of us in so many ways. And that thank you is not sufficient, but is certainly something I would like to say is on behalf of us all, thank you for all that you have done and all that you do. Thank you.
Well, thank you. It's been a real pleasure. Brad said to have fun. I think we've had fun. It's an interesting experience. I've not had to think about some of these things for a long, long time. So it's got me thinking about the past, which is not something I often do. I usually look into the future, but it doesn't hurt to think back over the past. So thank you.
Let man's petty nations tell their
You guys
Okay.
did
I
fine.
wanted to do all of the additional stories of like some of the outtakes, but when I can sort of chirp Kerry, there's a story, Brad, I'll tell you right now. So Kerry was amazing. He had these fantastic parties, like potlucks, where he'd invite his graduate students over and everyone would bring something and it would be at his home, and it was incredible. And at that time, you know, I'm a master's student, he has senior PhD students who've all gone on to incredible things. You know, there was Simon Dickinson and Karina, and like, we were wonderful people. And I remember going through the potluck, and it was in the dining room and getting things, and I was sort of pausing, and there's a picture of Kerry and Catherine, I want to say Ian and Sue, and you know, you're showing friendship with your colleagues, which has lasted with me. You know, I find, you know, some of my best friends are colleagues I work with, but you're out canoeing on a canoe trip, and I sort of turn to you and I talk about how I'm reading this amazing book about, you know, canoeing across Canada and how powerful it is. And I to this day, I remember you looked at me and said, "You have time to read?" So here's another fun tidbit was, Kerry, you took a bunch of us to, we went on a field site visit to a manufacturer. I'm going to forget the name, maybe Terravac. Pardon?
Oh, Terrafix could be. Terrafix and Solmax. I used.
Okay, so it was driving distance,
Yep.
and so I drove there and drove back because I think I had a license and was able to do that. So I rented the van, and I had a car full of sleeping graduate students in the back, and Kerry, not driving, sitting in the passenger seat, saying like, no, I can't drive. You're going to drive me, Ryley. And he pulls out his computer and works for 2.5 hours and then has a small pause. And it's like, oh, finally, Kerry's going to talk to me. We're going to have a conversation. Nope. He just had to change the battery pack in the laptop so that he could keep working. So I remember, I think it was Montreal. I don't remember, but it's like driving away and there's Kerry. Yeah. So those are my tidbits that can go in as the outtakes of.
Oh yeah, you know that red light's still on. You never know what you're gonna get at the end. I like that. That's amazing. I can't even use a computer in the car. Like, I don't know. It's not that I would get nauseous or anything. Like, I just can't physically do it. It doesn't work, and you get the weird lighting and stuff. And you had a spare battery?
Oh yes. Do you know I travel with 2 computers, 2 power packs, 2 separate screens, as well as my screen on my backpack weighs more than my luggage.